Hello everyone, in this video we'll be making Conway's Game of Life in Rust. So to get started, let's open up a terminal and navigate to a directory of your choice. Next, run the cargo init command to create your project. In this case, I'm calling mine Game of Life. And I've already done that step, so I will navigate into that directory. Now, if we run an ls, we can see all the files listed here, and we will need to edit this cargo.toml file to include a library called ggeasy that we'll be using. So use your favorite text editor, in my case NeoVim, to open up cargo.toml, and you want to add this line ggeasy equals 0.7. Make sure you have the quotations. Now exit your text editor or open up a terminal if you're using VS Code, and then run cargo build to build the library. And in my case, I've already done that, so it sped it up. But in your case, it might take 1 or 2 minutes. Now open up main.ls, which is located in the source directory, and you'll see it says println hello world. Now to run main.ls, you can always open up a terminal and run cargo run, and this will print out hello world. So cargo run will run your project, but in NeoVim, I will use a key binding to run it like that. Alright, so now let's get started making this game. So, first off, we need a state, which is basically what's going to store all the information for our game. Type struct state, and we're going to include some fields in here that are going to store what our game's going to have. So first of all, we're going to have a grid, which is a vector of another vector of booleans. Next up, we'll have an FPS, which is our frames per second, or like the update time that our game is going to run at, which is going to be an unsigned 32-bit integer. And we're going to have a running variable, which is a boolean, and this is going to tell our game if our game is running or not. So basically, our grid is a vector of booleans. And I should explain now what the Game of Life actually is. So basically, the Game of Life is played on a grid of any size. Whoops. And the grid has cells inside of it. Like so. These lines aren't really straight. But anyways, each cell is either dead or alive. So let's say this cell is alive. So any cell that's black is alive. Let's say this cell is alive, this cell is alive, and this cell is alive. Alright, so every single time the game updates, we're gonna test some cases. So for every cell that is not alive, if it has exactly 3 neighbors, and by neighbors I mean these 8 cells surrounding it. So if we're focusing on this cell, we're going to take a look at this 8 neighbors surrounding that cell. If there are 3 live neighbors, that cell too becomes alive, and we're going to shade it in to represent it. Now, any cell that is alive that has 2 or 3 neighbors is going to keep being alive. So, back when this cell was dead, right, let's take a look at this cell right here. This cell has 2 neighbors, 1, 2, right? So that means this cell will continue to stay alive in the next generation. However, if a cell has less than 2 or greater than 3 neighbors, this cell is going to die the next generation. So, this cell is going to die, and this cell is going to die. So, after 1 tick of our game, or like 1 generation of our game, this cell becomes alive, and these 2 cells will die. And then we can evaluate the same cases in this new position, where we have 2 cells like this, and as we can see, since they only have 1 neighbor each, they're both going to die in the next generation. And that's basically how the Game of Life is played. It's invented by a mathematician called John Conway, and it basically is it's really cool. It shows a lot of stuff about predictability and how math works. But we don't need to worry too much about that. So let me erase this real quick. And we'll go back to our code. Alright, so basically our game is going to be stored in a vector of booleans. It's going to be a two-dimensional vector of booleans that are either going to be true or false. True meaning alive and false meaning dead. Great. Now let's go into our main function. And we're going to type in let state equals state new. And we haven't defined new yet, so we're going to do that real quick. So let's go up here, and we're going to implement some methods for state. Some functions. So we're going to have a public function, new, which is going to return a value of self, of type self. And then we're going to say, we're going to return a state with a grid of vector of another vector of false. So every value is going to start off as false. So the entire grid is going to be blank, and we're going to make this have some dimensions. And since we're going to use the dimensions a lot, we should make them into constants. So go to the very top of your file, and we're going to say const cell size, which is going to be a tuple of float32, and I'm going to set it to 20.0, comma 20.0. And this is basically how big each individual cell is going to be. So, in terms of pixels. So each cell is going to be 20 pixels by 20 pixels. Alright, now let's specify the grid size, which is also going to be a float32, and I'm going to set it to 40 by 40, which means this entire grid is going to be 40 cells by 40 cells. Nice. Now, one last thing we should specify is the window size, which is how big the window is actually going to be on our screen. And this will be a really quick calculation. So const window size, which is also going to be a 32-bit float, and we're going to set it to cell size dot 0 times grid size dot 0. So basically, our cell size, our x value of our cell size, like the width of the cell size, times how many cells there are going to be in the grid in the horizontal position. That's going to be our first value, and our second value is going to be cell size dot 1 times grid size dot 1. Nice. Next. Actually, no, that's all the constants. I lied. So let's go down to grid. I mean the state. And then we're going to go into the grid field of state, and inside of here, as you can see, there's two vectors. So this macro in Rust basically just creates a vector filled with this contents. It's like this value. So it's going to make a vector of false, and we're going to say the vector has a size of grid size dot 1, and we need to cast it to a U size, because grid sizes are U sizes. Now basically our x direction of our vector is going to be grid size dot 0 as U size. So if this sort of makes sense, we're gonna make a vector that's basically 40 tiles wide, right? And each of those vectors is going to contain a vector which is going to be 40 cells, like, tall, I guess you could think of it as. So basically it's just a two-dimensional vector. A vector inside of a vector. Now, of FPS, I'm just going to set to 1 for now. So it's going to update once per second. And then we're going to set running to true. Great, now state is done. So let's go down to main. And let's make a window. To make a window, we're gonna get the variable ctx and event loop from the context builder, which is going to be imported from GGEasy. And we're gonna make a new context builder of our title, which is going to be Conway's Game of Life, and the author, you can just put your own name. Great. Now I'm going to set the window mode to window mode default, which is going to be like a default window, and then we're going to set the dimensions to be window size.0 and window size.1. So 0 is going to be the x value of window size, and window size.1 is going to be the y value. So we're basically going to make a default window of size 20 by 40 pixels by 20 by 40 pixels. And then finally, we're going to run build and just catch any errors with the question mark operator. And finally, we can type event run with context, event loop, and state. So this is going to run the window, and so this question mark operator actually returns a result option. So we need to return a game result from main, which is going to be imported from GGEasy. And yeah, so undeclared create a module event. Hold on. So we need to import event from GGEasy. So let's go up to GGEasy and we're going to import event as well. And that should fix the error. And we need an event handler for state, which is going to be basically just, as the name suggests, handle events while the game runs. So for now, let's go up here and we're going to implement event handler for with a game error for state. And we're going to have an update function, which for now we're not going to put anything inside. We need to update and a draw. So down here, so about all the errors, function draw, and we're going to have a draw function as well. Now you'll see it expects a result from update, so let's just return OK. So we're going to return an OK for update, and also an OK for draw. Now all the errors should be gone, that's good. And we can execute our project. Again, you can run cargo run to start this project, or in my case, I'm just going to use a keybind from NeoVim. Now, it might take a second. And as you can see, I'm actually not seeing anything here. And this is because, well, a window's opening for me, but you just can't really see it, because we haven't done any drawing yet, so it still has just the default things. If you see right now, I can move this window, but nothing's being drawn on top of it. So, let's draw some stuff. Inside the draw function, we're going to say graphics clear. And we're going to clear the context with a color of, let's say, color, which is going to also be imported from GGEasy. And that's strange. We're going to need a different color from GGEasy. So it's going to be GGEasy graphics color, and then we're just going to say white. Why not? It's going to be a white screen. And after that, we want to go down here, and we want to say graphics present CTX. And this is just basically going to, it's basically just gonna draw all the stuff we want to on to the screen. And if you used an expander, like, to make the draw function, you want to remove the underscore from CTX. So we're going to clear the screen with the color of white, and we're going to draw that to the screen with present. And I have a question mark here because it's going to catch all the errors that's going to come out. Let's save that and try running it. There we go. Now we have a blank window. Great. So now comes the tricky part. We got the window and everything set up. So now we gotta set up our game. So let's make a quick update function up here. So inside of update, we're gonna say while timer, which is gonna be from DGEasy, check update time, CTX, and self.fps. So while the timer is going to check this FPS to see if like it's time to update, right? If it's time to update, we're gonna say let mute quotes, which is gonna be a vector of usize equals a blank vector. So what this is basically doing is quotes is going to be a vector of coordinates, basically. And these are all the coordinates we want to change. It's an easier approach this way. And this is a problem it solves. So let's say we go back to our drawing board, and we make a quick diagram like we did before. Right? So let's say these three cells are alive right now. Now, one big problem when updating is we can't just directly mutate the board. Because let's say, for instance, we update right now, and we check for cells that are dead but need to be turned alive. So we'll go through and we're going to see that this cell needs to be alive, right? Because it has 3 live neighbors, exactly 3 live neighbors. So we're going to shade this cell in, and as you can see, this creates a problem. Because if we go down to like this cell, for instance, now instead of having just 1 neighbor, this cell now has 2. So this cell should have been dead before this, after this generation, but this cell still is alive because we added in a new cell while we were still checking for the conditions. We added in this new cell while we were checking for the conditions, because that cell should have been dead if this cell didn't exist. So instead of just going through and mutating our vectors, what we want to do is we're going to make a vector of coordinates, right? So it's going to contain some coordinates. Let's say, like, for instance, this is going to be an x of 1 and a y of 1, this cell right here, right? So this is going to be one of the coordinates inside of our vector, and this vector is storing all of the coordinates of the cells that are going to be flipped, right? So we know that this cell needs to be flipped, but instead of directly mutating this cell, we're going to store that inside of the vector. So now when we go to a cell like this one, which has only 1 live neighbor instead of 2, we're going to know that this cell needs to die, the next generation, right? So we're going to also put that cell, which is going to be 1, 0, inside of our vector. And our last cell right here is this cell, which also has 1 live neighbor. So that cell is going to die the next generation, so we're also going to store this cell, which is 2, 2, inside of our vector, right? So once we have a vector of all of the cells that need to be flipped, so we're going to turn this cell off, this cell on, and this cell off. Once we have a vector of all of these, we can go through, after we've done every single calculation, we can go back through and then change these cells. So we're going to erase this one because that one was in the array, or the vector, I guess. we're going to change this one to alive because that was in the vector. And we're going to change this cell to dead because that was also in the vector. So basically, this vector is just storing all of the values that need to be flipped. So true to false, false to true. So now we understand what this vector is doing, we can go back to our code. And we have an error here because I have another underscore for my CTX. So this code is going to be a vector as I just described over here. And we can go down here and we can start looping through all of the cells. So we're gonna go for I in 0 to grid size, and this is how you make a for loop in Rust, .0. So I is gonna store the x value of the coordinates as usize, because we have the index vectors with usizes. So we're gonna cast grid size.0, which is the x like width of our grid, the width of our grid as a usize, and we're gonna loop through it. Now we're gonna do for j in 0 to grid size .1 as usize. So j is going to be storing the y value of our coordinate. So now we got both coordinates of our cells, our x and our y, right? So now we can check our cell. And how we do that is with a really neat trick like this. So first of all, we need to get all of the x and y values for the left. So let's say we're talking about, let's just fill in a couple more cells. Let's say we're talking about this cell right here, right? We're going to be talking about this cell. The 8 neighbors it has are just variations of adding something to its x and y coordinate, right? So this side, we're going to add 1 to the x coordinate, right? If we go this way, we're going to be subtracting 1 from the x coordinate, right? And if we stay still, we're going to say that's 0x, plus 0x, right? And that applies for the y as well. So if you go down, we're going to be adding 1 to y, because we this is like 0, 0, this top corner is just 0, 0 when we draw a game. Going up is going to be minus 1y, and staying still is going to be plus 0y, right? So now we can get to every single cell, every single neighbor, using all of these like coordinates, right? So let's say we want to take a look at this cell right here, this corner cell. That's just going to be this x coordinate. It's going to be this cell's x coordinate minus 1. It's going to be its y coordinate minus 1 as well, right? We have this minus 1 right here. We have this minus 1x right here. Y minus 1. Right, so this neighbor's coordinate is x minus 1, comma y minus 1. And we can actually see all of these different cells right here, and we can represent them as just subtracting or adding 1 from the x and y coordinate. So we're gonna come up here inside our x loop, for I in 0 to grid size.0. We're gonna get the left and right values for x. But we have a problem, and that problem is, let's say we have a grid, right? Let's say we have a grid here. If we're taking a look at this cell right here, if the current cell we're on is this one, and we try to look 1 to the left, right? That's not gonna work, because that cell doesn't exist. This is just nothingness. Rust is gonna give us an error because we're trying to index at -1. Because this x is 0, and x minus 1 equals -1, and we don't have a -1 index on this array, or on this vector. So instead, we want to check if going back to -1 will make it go off the grid, and if it goes off the grid, we're just going to loop around to this cell. So this cell is now the left neighbor of this cell. Do you sort of understand? So this cell is going to be the left neighbor of this cell. This is going to be the top left neighbor. this is going to be a bottom left neighbor, this is going to be the right neighbor, top right, top, and bottom neighbor. So basically just going to wrap the entire grid around to itself to get the left and right neighbors. So in a for loop right now, we're going to say let left equals if I is greater than 0. So if I isn't 0, if this cell right here isn't on the very far left, if it's like here or here, we're going to set left to be I minus 1. So we're going to go 1 to the left if and only if it's not the left edge of the board. And otherwise, we're going to set it to grid size dot 0 as u size. We're going to cast it to u size, obviously, and then minus 1. Right? So, if the cell we're looking at isn't on left edge, we're just going to take the normal left side of the cell, right? We're just going to take the normal left side of the cell. But if it is on the left edge, we're going to wrap around to this cell. And we're going to do the same thing, the same logic for right. Let right equals if I is less than grid size dot 0 as u size minus 1. If it is that, we're going to set it to I plus 1, so going 1 to the right, and then else, we're going to set it to 0, which is the furthest to the left. Great. Now we're going to do the same for up and down. It equals if j is greater than 0. So basically, instead of using x right here, we're going to be using j. I mean, if instead of using I right here, we're going to use j, because j is the y value now, and we're checking y. Alright, so now we have up, down, left, and right, and there's a bunch of arrows showing up right now because I'm like sort of not using these variables. So we have left, right, up, and down, and now we can get all the neighbors of our cell right now. And this is gonna take quite a bit of code. So we're gonna say let neighbors. And a cool thing about Rust that I want to mention is if in Rust we have a value which is true and we cast it to like an int, right? It's like an i32 or something, right? If we cast a true value to an i32, it's going to change false to 0 and true to 1. Right, so false is going to be 0 and true is going to be 1. And this is great because if we want to count, if we want to count the number of, I don't know what I did there. If we want to count how many neighbors a cell has, we can just take a look at all of the booleans around that neighbor, right? So let's say we have a cell, here, and its left neighbor is alive, right? If this cell's left neighbor is alive, that left neighbor, when we index it, it's going to return a value of true, right? And if we cast that true to an integer or something, it's going to return 1, right? So we can add this one, and this one, and this one, and let's say we have a dead neighbor, we're going to call that 0, right? So we're going to add all of these true and false values, and if we just add up all of these boolean values, we're going to get the total number of neighbors this cell has that are alive. So we're going to say let neighbors equals self.grid at index left j. So basically this is a left x, a x value for the left and j is just basically adding 0 to the y. So we're gonna be getting this cell, right? Left j as u8, an unsigned an 8-bit unsigned integer, plus self.grid index left up. So basically, we're just going to be going around in a circle, right? We're going to get this cell first, and we're going to get this cell, this cell, this cell, this cell, this cell, this cell, and that cell. Right? We're going around in a circle, and this might be worth just copy and pasting. So what I'm gonna do is just copy and paste this. 3, 4, 5, 6, 7, 8. We have 8 things. So we're gonna take the left j, left up, I up, which is again 0 for x, plus 1. I mean minus 1 for y. Right up, right j, right down, I down, and left down. Right? So now we can see right here we have 1, 2, 3, 4, 5, 6, 7, 8. We have all 8 neighbors of a cell, and we basically just go this, 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 and this. Right? And since we cast them to U8, they're either going to be 0 and 1, and once we add them together, neighbors is going to be a number from 0 to 8. And now finally, if self.grid at ij is true, so if this cell is alive and our neighbors is less than 2, or neighbors is greater than 3. So if our cell is alive and it has less than 2 neighbors or greater than 3 neighbors, we want to say chords dot push I comma j, and then else if not self dot grid ij. So if the cell isn't alive and we have exactly 3 neighbors, we also want to push this to the quotes, right? So if we have an alive cell with fewer than 2 or greater than 3 neighbors, we add that coordinate to the quotes vector. And if our cell is not alive and we have exactly 3 neighbors, we're going to also push that to the quotes. And then finally, after our loop is done, right here, right here, for chord in quotes, we're going to say self.grid at chord.0, chord.1, this symbol equals true. And what this operator, it just basically says if it's true, make it false. If it's false, make it true. So we're gonna flip the value of the cell at index self.grid chord 0, chord 1. Right. So now all of our logic for the game is essentially done. And we can start playing around with this. So let's go down here and let's just test something out, right? Let's go to let's say let mute. So let's have a mutable state right here. State.grid. I'm just gonna pick a random cell 5, 6. Oh, not 5, 6. Index 5, 6 equals true, and we're just gonna turn a couple of more cells on. If we run this now, one problem. We have not drawn the grid yet. So that's probably something we should do. So this is the next part we're gonna do, which is drawing the grid. So all of our values are actually being stored right now. Like this is functional, but the main thing is we need to find a way to draw this to the screen, and that's what we're gonna do in the draw method right here. So let's say for I in 0 to grid size dot 0 as usize, for j in 0 to grid size dot 1 as usize. Oh, I forgot 2 periods. We're gonna say let rect. So this is how you make a rectangle in GGeasy. We're gonna say let rect equals mesh dot new rectangle. We're gonna give it ctx. We're gonna give it draw mode dot fill, or draw mode fill. I kind of want to just import draw mode real quick. Draw mode fill, and we need the boundaries. So for the boundaries, we're gonna do a little bit of math here. So we're gonna say rect new, and rect in this case is sort of like a rectangle, but like the boundaries of the rectangle. Our x value is gonna be I as 32-bit float times cell size dot 0. So x right now is I right now is our x coordinate, right? Or sort of like our x coordinate, but in terms of grid, right? That might be kind of confusing. Hold on. Alright, so basically, we have this grid right here, right? And our I and j are just indexing what this is. So I equals 0, 1, 2, and j equals 0, 1, 2, right? So for instance, if we want to draw this rectangle right here, currently I equals 1 and j equals 1, right? But if we try to draw this rectangle at position 1, 1 on the screen, it's going to be like in this tiny corner as a little dot, right? Because these are sort of like relative to the grid, right? So these are coordinates for the grid, but if we multiply I times our our cell size, right, which is I think 20 pixels, it's going to say take this I value and multiply by 20. So it's going to go 20 to the right here. It's going to go 20 to the right. J is going to go 20 down, since 20 is our cell size dot 1. It's going to go 20, 20, and it's going to actually draw a 20 by 20 rectangle instead of like a 1 by 1, because the 1 by 1 is just a single pixel, like a measly little dot. 20 by 20 pixels, you can actually see the grid. That's all. So I as float 32 times cell size dot 0, comma j as f32 times cell size dot 1, and then cell size dot 0. So basically this rect struct. Oh, I went to the top. Oops. This rect struct is going to store the x coordinate, the y coordinate, the width, and the height, right? So something weird about how games are rendered usually is the x coordinate and the y coordinate, it's on the top left corner. So if this is a screen right here, if this rectangle is a screen, the x and y coordinate is this point right here. It's the dot on the top left corner. That's our x and y coordinate. So we have our x as I as f32 times cell size dot 0, j as f32 times cell size dot 1. Our width and height is going to be our width and height set as the constants, and as our color, let's just make it black. So now we have a rectangle, like a rectangle mesh. Oh wait, I need to import rect. That's weird. 1 second. I forgot to import rect inside of graphics. So let's import rect as well. Let's go down here. And we have this rect object right here. Right, so this mesh, and now we can draw this to the screen. We can draw this to the screen down here, Oh wait, first off, we need a question mark because we need to catch any errors that come up when we were making the mesh. So we say graphics, draw CTX. We're gonna pass a borrow to the rect, and we're gonna have a point2. So point2, this is like where it's gonna be drawn, but since we already defined the coordinates, this can just be x 0.0, y 0.0, and yeah. I don't mean to wrap this in parentheses. And I type draw on. Alright, there we go. And since we have an unused result, we're just gonna put a question mark at the end to catch that. And then, yeah. So now down here, we can draw another rect. Actually, no, that's fine. All of this should be good. So let's try this now. So we should be drawing squares to the screen now based on the grid. And let's see if this works. You know what I forgot to do? I forgot to check if that cell is actually alive before drawing this cell to the screen. So let's do that real quick. If self.grid at ij is alive, that's only if and only that cell is alive, we're gonna actually draw a black square to the screen. There we go. As you can see, it's already playing out, and it's stuck on this state now because that's like a constant state. It's not gonna change. It's not gonna die. It's not gonna continue to thrive. But yeah, that works. So drawing the cells to the screen right like this is already working. Now, our final thing to do is we're gonna add mouse input, and we're gonna add some other like functions that you can control with your keyboard. That way, you can actually like draw on the screen and turn on cells with your mouse instead of having to go through state.grid and setting all of these to true. So let's remove that. Let's remove the mute from state, and down here we're gonna have a handler for key functions. So we're gonna say fn mouse button down event, and we're gonna say self.grid, and we're gonna need these x, y, and yeah, we're gonna need that. So self.grid at index x divided by cell size dot 0 dot floor as usize at index y divided by cell size, oh my gosh, cell size dot 1 dot floor as usize not true. So that was a mouthful. So the logic behind this is kind of confusing. So x is a mouse coordinate on the screen, right? So x is a mouse coordinate on the screen. Let's say we have a screen. Oh my gosh. Let's say we have a screen like this, right? This is gonna. Oh, that's a terrible rectangle. Actually, let me try to make that better. Let's say our screen is like that, right? And our mouse is right here, right? Our x, comma y value right here is not representative of the actual grid, right? That x is gonna be something like 532 point something. No, 532 comma like 410 or something, right? That x and y value, it's in terms of pixels. So what we're gonna do is we're gonna divide that by cell size dot 0, right? We're gonna divide 532 by 20 and then we're gonna flow that. Flow just means basically like cut off the decimal point, right? So 532 divided by 20, that's like 5 times 5, 25, 26. That's like 26 point something, right? 26.1, I'm just gonna guess something, right? What we're gonna do is we're gonna cut off the stuff behind the decimal point right here, and we're just left with 26. And this 26 is now a new value for like what index we're at, right? That means that 26 to the left on the grid is going to be where the cell is going to be at. So we're going to do that for the x, and we're going to do that for the y, and then we're gonna just invert the cell. We're gonna, if it's true, if it's alive, we're gonna make it dead. If it's dead, we're gonna make it alive. Yeah, and some other quality of life functions we can add is function key down event. And I just kind of like putting if key code, which we'll need, yeah, if key code equals event key code dot space and not repeat. And repeat just means that the keyboard, like if you hold down a button, it's gonna repeat the key. We don't want that to happen here, so we're gonna check if it's not repeat. If it's like that, then we're gonna say self.running. We're gonna invert that. Right? So basically we're gonna use space to like to start and stop the game, or like pause and resume. Alright, so that's pause and resume. And let's try running that now. So now we can see if we start clicking on the screen, it's going to actually start making cells appear. And what's going on right now, why it's disappearing, is because I set the game to start running automatically. I kind of don't want to do that. We just want to start and stop with the space instead. So up here in your state, we're going to change running to false. And let's try that again. And now you can actually see that if I... we forgot to check if we're running before we update. So, let's go to update. And we gotta check, not only do we want to check if the timer is running, if like our FPS is updating, we're gonna also check if self.running. So only if we're running do we actually want to update. That's something I missed. Yeah, there we go. So now the game is stopped. Let's make a pattern. This is a gospel glider gun. And now if we press space, we can see it run and step through all this things. And then if we wanted to stop, just press space again and it stops. Great. Now I have a couple more key events that I like to add. And we have if keycode equals event keycode up. So this is just we're gonna use the up and down keys to control the FPS. So we're gonna say self.fps plus equals 1, because Rust doesn't have an increment operator. If keycode equals event keycode down self.fps minus equals 1, and if keycode equals event keycode delete, and I'm just going to use the delete key to clear the screen. You don't need to add this if you don't want to, but we're gonna basically just going to set self.grid back to a blank vector. So vector false grid size .1 as usize, grid size .0 as usize, And so we're basically just gonna use the delete key to clear the screen. Right, it's gonna reset the vector. And that's pretty good. Another thing I want to do is I want to make like horizontal and vertical lines showing where the cells are. So let's go up here to our event handler, and we're gonna actually our draw function, and we're gonna draw our lines. So if we go down here, we can say if I equals 0, because we don't want to be drawing a line at the very edge of the screen. It just looks bad. Just continue to the loop, and let line equals mesh new line, and we're passing the CTX. The points are going to be a reference to a borrow to a vector of 0.2 of xi as f32 times cell size dot 0. So this is going to be the x value of the line, the first point of the line, comma y as 0.0, comma 0.2, which is going to be the same x value, actually no, a different x value, x I as f32 times cell size dot 1, comma y is going to be window size dot 1, and we need a width. I'm just gonna set the width to something like 2. The color, we're just gonna make it, color black. Let's make the line black. Pretty simple. And this could return a result, so let's catch that. And we're gonna say graphics draw at CTX, pass a borrow to the line, and 0.2 at x 0.0 and y 0.0. And then at the end here, let's capture the result. And that's going to be all our lines for the x. Unnecessary parentheses. Oh yeah, we need to put a comma here. And we need to make the line width to float, so put a 0.0. So that's going to be all x lines. Now we need to do the same thing for the y. Oh wait, that was my bad. All of this stuff we just wrote, that's the y line. So move that down here into the y loop. And then we'll just say let. You can just basically just copy the same thing. It's really the same thing, but we need to reverse the x and the y values. So we'll just say x, which is j as f32, j, and this is actually going to be y, it's going to be x, this is going to be x, this is going to be y, and we're going to say x 0.0, x window size dot 0, because 0 is the x window size, y j as f32 times cell size dot 0 times cell size dot 1. Oh, and this one I mistyped. It's supposed to be cell size dot 0. Yeah. So that was a bit confusing. If you want to, you can just copy the code. It's basically getting a line. It's making a new mesh of a line. It's getting the endpoint, the starting point and the endpoint, and it's going to draw a line down or horizontally in this case. So now if we run this, we can see that we have these lines here that are being drawn, and we actually know which cells we're going to be clicking. So we click a few cells, we can turn off the FPS by a little bit, and we can run. Neat. So yeah, that's about it. If you want to, you can add some more functions to this. You can make like some more keybinds to do some cool stuff. But yeah, if you have any questions, leave them down below in the comments. This is a pretty long video, and I probably didn't explain some stuff really well. But yeah, if there's something you don't understand, leave it in the comments, and I'll try my best to explain it. But as always, thanks for watching, and see you in the next one.